Welcome to week 16 in geometry. We are in the week 16, also week of December 6th. So at this time, please make sure you've got your math notebook out and you're ready to take good notes that are going to help you when you go to do this week's assignments. And we are actually going to do a warm-up problem that comes from Unit 2. Where we are going to look at the two triangles below. We've got triangle SLN and triangle NKW, and we want to see if we can prove those two triangles are congruent. So let's think back to the ways we learned that we can prove two triangles are congruent. And I want you to do that in your math notebook right now. And go ahead and click pause so you can do that, and then when you're ready to check your work with mine, go ahead and click on play. All right, so there are several ticks on this triangle that tell us that some sides are congruent. So we've got side LN is congruent to side NW. We also have two ticks on SN, which lets us know that side SN is congruent to the side NK that also has two ticks. And then, last but not least, we've got one arc right here and another arc right here that lets us know that those two angles are congruent. So, what theorem did we learn back in Unit 2 that will help us use these congruent parts to prove that these two triangles are congruent? If you said side, angle, side, you are correct. You are correct because we've got that angle that's sandwiched between those two congruent sides. So taking a step back to what we talked about last week and what we learned about all the way back in Unit 2, this term congruent, what does it mean when we say that two objects are congruent? It means that they are the same size and the same shape. So that's kind of our generic definition there. But to be congruent, we can take it a step further and say that all corresponding, so when we've got two figures, remember corresponding means located in the same position, all corresponding sides and angles are congruent. They're the same. So when we have congruent, that means that all of the corresponding sides and angles are going to be congruent. Well, last week we started talking about similar. We started talking about similar, and we're actually going to use some theorems to prove that two triangles are similar, just like we use some theorems to prove that two triangles are congruent. So similar, remember, if you remember, is the same shape, but it can have different sizes, different size. And because it can be different sizes, that means that all corresponding sides, we learned this last week, are going to be not the same anymore. So corresponding sides are not going to be congruent, but instead they're going to be proportional. So make sure you write this down somewhere in your math notebook. And then the corresponding angles, I'm kind of running out of space over there, corresponding angles will be congruent. So the big difference between similar and congruent is that the sides. For congruent figures, the sides would have to be congruent, the corresponding sides, whereas when we're talking about similar, the corresponding sides just need to be proportional. The corresponding angles will be congruent for both congruent and similar. The biggest difference is that the corresponding sides for similar objects, or similar figures, will need to be proportional. So if we think back to not even last unit, it was unit 2, we learned a couple different ways to prove that triangles are congruent. Can you remember all those different ones? So we know we did side, angle, side. We did side, side, side. If we can prove that two angles and their included side are all congruent, then angle, side, angle is a theorem that we can use. And then last but not least, angle, angle, side. So this week we're going to more focus on proving that triangles are not congruent, but that triangles are similar. So that's what we're going to learn about this week and what I'm going to show you in this recording. Before we get there, this week you guys are going to complete so we are in unit 4. We're going to complete unit 4 session 3, which is proving triangles are congruent, which I'm going to go over right now. Then you're going to take the unit 4 quiz, which is going to cover sessions 1 through 3. And then you're going to do unit 4 session 4, where we're going to apply properties of similar triangles. So just a heads up, we are quickly approaching the end of the school year. I think we've got about 2.5 weeks, not in the end of the school year, 2.5 weeks till the end of the semester. Sorry if I got you excited thinking it was the end of the year, but we are about halfway through the school year. We're about to finish semester 1, so I'd always want to keep you guys informed with the timeline we're looking at till the end of the semester so that you guys can be proactive about getting your grades where you want them to be. So we are really in crunch time. If you are behind and you need to get your grade up, you need to be doing that now. So remember that. Most of you guys are doing a fantastic job, so keep up the wonderful work. About 2 more weeks of hard work, and then you get 2 weeks off for winter break, so hang in there. All right, so we just talked a little bit about similarity. So what are similar triangles? And we really, I think, got this term similar down. So when we've got 2 triangles that are similar, all the corresponding angles are going to be congruent. So we just chatted about that. So in these 2 figures, every set of corresponding, remember corresponding just means they're located in the same position. So every set of corresponding angles, and you can see by the number of arcs around each angle, lets us know that those are corresponding. So you note that there's different amounts of arcs, and that's so that we know which angles are corresponding and that they are in fact congruent. So corresponding angles are always going to be congruent. Where it gets a little different is that the corresponding sides, in order to be similar, the corresponding sides are going to be proportional. So here, this side AB between these 2 angles that we know are congruent because this angle has 1 arc and this angle has 2 arcs. This angle has 1 arc, this has 2. So we know that these 2 sides are corresponding sides. So I'm going to go ahead and I'm going to erase my arc colors and just focus on the corresponding sides so that we can color those. So this side here corresponds with this side here. And we know that those 2 sides have to be proportional. So we can find the scale by setting up a ratio between side AB and DE right here. So if we set up a ratio, we know that side DE is 20 and side AB is 10. 10 divided by 20 is 2. And then we can continue to do that and set up ratios with our other set of corresponding sides. So let's see here. We've got side BC. See how there's 2 arcs here and 3 arcs here for those angles? So we know it must correspond with this side here that's also between the angles with 2 arcs and 3 arcs. So that would be side BC and EF. And we can also set up a ratio, which would be side EF, which is 12, and side BC, which is 6. That also reduces down to 2. So you can see that pattern that is occurring between all the sides, that they are in fact proportional. They have this same scale factor. So that is what we mean by similar triangles. And just like we had several different ways to prove that two triangles were congruent, we've got some theorems that help us out in in proving that two triangles are similar. And those three ways are AA for angle, angle, and we're going to talk more in depth about these on the next coming slides. Side, 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 and side, angle, side. So these two look very familiar to what we did in Unit 2 when we were proving two triangles are congruent. I know they're the same three letters, but they actually represent things a little bit differently because we're talking about similar triangles now. So let's go to the next slide and look at these theorems more in depth. So the angle-angle similarity postulate says that if two angles of one triangle are congruent to two angles of another triangle, then those two triangles must be similar. So here, these two corresponding angles are congruent. These two set of corresponding angles are congruent. Therefore, we can prove that triangle LMK is congruent to IJK using the angle-angle similarity postulate. So that's our first postulate. Second one, side, angle, side. So again, we're using this for similarity this time. So we're using this for similarity, so it's going to be a little bit different. Before, if we could prove that two corresponding sets of sides and the included angles were congruent, then the two triangles were congruent. Well, now we're using it for similarity. So this theorem states that if one angle of the triangle is congruent to an angle of the second triangle, then the sides, including those angles, need to be, and if they're proportional, then the two triangles are similar. So the sides need to be, the set of corresponding sides need to be similar. So in this case, let's make sure, or proportional, not similar, they need to be proportional. So let's see if that's true in this case. So this side here would be corresponding to this side. So if we set up a proportion, that would be 6/4. And then we'll set up a proportion with the other two sides, this side here and this side here. And I would do 3/2. And 6/4, if we divide out a 2, what does that reduce down to? 3/2. So these have the same scale, so we know that those two sets of sides are in fact proportional. So because the sides are proportional and they've got one set of corresponding congruent angles, then we can prove that these two triangles are in fact similar using the side angle side theorem, similarity theorem. I'm going to go on to the next slide now. We're going to talk about that third theorem, the side, side, side similarity. So here, if the corresponding sides of two triangles, if the corresponding sides of two triangles are proportional, then the triangles are similar. So really, if all sets of corresponding sides, if they're proportional, then the triangles are similar. So let's see in this case, if these sets, so 6 and 8, we can say that that is 8/6, which, and then our next ratio is the same thing, for we have another 8/6, so we know that those are definitely going to reduce down to the same scale for sure. And last but not least, we've got 4/3. And if we divide a 2 out of the 8/6, guess what we get? 4/3. So every single one of these sides has the same scale factor, so we do know that those are proportional. Therefore, we can use the side, side, side similarity theorem to prove that these two triangles are in fact similar. All right, so I've got two triangles here, and I want you to take a moment and decide if we can prove that these two triangles are similar, not congruent, but similar using one of the theorems, and I listed all three of them here just for you guys to have it easier. Take a look at all three of those and see if it fits any of those. Okay, so I see that we've got one set of congruent angles, one set of congruent corresponding angles. So we know we can get rid of the side, side, side because we do have a set of congruent angles. Then we've got two marked sides that sandwich in the angle. So we've got a long 5 and a 4, 15 and 12. So I know 5 would have to correspond with 15 because those are the two longest sides. And then the other angle that we have, or not the angle, I'm sorry, this side, the length that's given is this one here, which would correspond to this one. So are those proportional? Are those in fact proportional? Do they have the same scale factor? 15 divided by 5 is 3, 12 divided by 4 is also 3, so we know that they are in fact proportional. So we can use the side, angle, side to prove that these are similar. And yes, they are similar. Okay, and this is what you're going to get to do this week, is use these same theorems. So we're going to stop here, and let me put up the key phrase assignment. So in this recording, I introduced you to the 3 theorems that you can use to prove that two triangles are similar. And what are those 3 theorems? You need to tell me what those 3 theorems are. I do have the directions below to complete the key phrase assignment if you need a reminder. Otherwise, remember I'm here if you guys need any help this week on working on any assignments or have any questions about the lessons. Remember I'm here to help, so send me a quick message. Otherwise, have a fantastic rest of your week.